Continuing with what we did yesterday, I did the problems yesterday like the ones I'm going to do today, where yesterday they were only asking for one missing part, and I said let's go ahead and find all the missing parts. So just some more examples involving that, just really reinforce how to do this. And just to make this problem like a problem in the book that might come up, let's suppose that instead of 24 degrees, let's call this 24 degrees, 13 minutes. Let's say that's 24 degrees, 13 minutes, just so when the problems that involve minutes come up, we can handle that scenario, because that is happening on a few of the homework problems. So, find the missing parts of this triangle. The missing parts, of course, are H, B, and Y. B is an angle, H and Y are sides. And just like I told you yesterday when we were doing these problems, we determine how to do a problem like this based on what we know. We have a right triangle where we know a side and we know an acute angle. So when we have that information, we're going to use the I know one acute angle and one side of a right triangle technique to find all the missing pieces. So step 1 says find the other angle, which in this case would be angle B, by subtracting from 180. So notice the two angles I know. This one, of course, is 90 degrees. This one's 24 degrees, 13 minutes. If I were to add those together, 90 degrees plus 24 degrees, 13 minutes, that comes out to 114 degrees, 13 minutes. Keep in mind that things of the same type add together. So degrees and degrees make a new degrees. There's no minutes on the 90 degrees, so nothing plus 13 makes 13 minutes. So if I do 180 minus the sum of the other two angles, that's how much is left for the third angle. So what I've got to do here is 180 degrees minus 114 degrees, 13 minutes. Now for subtraction purposes, to subtract 13 minutes, I have to have some minutes to subtract from. Right now I'm subtracting 13 minutes from nothing. I can't do that. So what I need to do is borrow 1 degree.
That's what I was going to say.
So I'm taking 1 degree away from the 180. That 1 degree is equal to 60 minutes. And that's how we create this scenario where we can actually subtract the minutes. So we have some number of minutes to subtract from. So,
how is it 60 minutes?
Because 1 degree equals 60 minutes. So if you recall when we talked about degrees and minutes back in chapter 10.1, you know, if you imagine a protractor, here's a protractor. If you have the degrees, let's say this is 3 degrees, this is 4 degrees. If you cut that into 60 equal spaces, each one of those spaces would be 1 minute. So it takes 60 minutes to make 1 degree. So we're borrowing 1 degree off the 180, so the 180 becomes 179, 1 less degree, and that 1 degree is equivalent to 60 minutes. Okay, and again, that's how the borrowing works. That allows us to subtract. So 60 minus 13 makes 47 minutes, and 179 minus 114 makes 65 degrees. So 65 degrees, 47 minutes. And it says find the missing parts. I'm just going to make an answer box over here. I'm just going to say B equals something, H equals something, Y equals something. Let's just ask to find 3 things. I'm going to make a box there to put all the stuff I'm supposed to find in there. So, oh, that's not good. So, moving around. So B is equal to, and again this is B, right? 180 minus the other two angles equals B. So B is 65 degrees, 47 minutes. The next thing I do on a problem of this variety is I pick one of the acute angles, doesn't matter which one. They're both fine. I'm personally going to pick the one that I was given. So I'm going to pick, seriously. There we go. I'm going to pick this acute angle here. And for the acute angle I pick, this is step 2 that I'm doing right now, I want to determine the opposite side, the adjacent side, and the hypotenuse for one of those acute angles. So again, I'm focusing on this acute angle here. It doesn't matter which one you pick, just pick one. And if I go across the triangle, that's the opposite side. If I start at the right angle and go across the triangle, that's the hypotenuse. And the remaining side is the adjacent side. As long as the right angle's in the corner like that, it will always be, but if the triangle's turned around in some way, like for example, if I had a triangle that looked like, let's say, here's my triangle, but then it's turned like that. They're all slanted now, right?
Yeah.
So again, if the right angle's sitting right here, the right angle's always opposite the hypotenuse. So as far as being able to say always, it's always opposite the hypotenuse. It's not always the slanted side. More often than not, it is though. And if you draw it in a standard position like this, where the right angle's in the corner, then absolutely the hypotenuse will be the slanted side. Right. So that's all step 2 is. You pick an angle, either this one or this one, not the right angle. But again, if they've already given you an angle, you should go with that one. Opposite, hypotenuse, adjacent, identify those 3 sides. And then we're going to use SOHCAHTOA in order to write the trig ratios. And if I look at SOHCAHTOA, what I told you yesterday, that 2 of the 3 work and the other one doesn't work. And if you figure out the one that doesn't work before you start, then you can avoid one of these. So what I do not know is I do not know the opposite and I do not know the hypotenuse. If I look over to SOHCAHTOA and see which of the 3 ratios involves those sides, the opposite and the hypotenuse, that'd be sine. This one here has both pieces I don't know, so that one there is not going to help me whatsoever. So you can just toss it and say, I don't need that. All right? But I want to write the cosine and the tangent ratios for the 24-degree, 13-minute angle. So I'm going to have cosine of 24 degrees, 13 minutes equals adjacent, which is 9.5 over hypotenuse h. Right. And then I'm going to write the tangent ratio. Tangent of 24 degrees, 13 minutes equals the opposite, which is y, over the adjacent, which is 9.5. Now, if you recall from yesterday, I told you when you write these ratios, put the trig ratios over the number 1 to create a proportional look. Proportions can be solved through cross multiplication. And use a calculator to evaluate the cosine and tangent of this angle. So, if I go to my calculator, and I want to be in degrees, not radians, so I'm going to switch my calculator over to degrees. All right? And as long as you are using these gray calculators, they're all set to degrees already. Anyway, if I type in cosine of 24, now to get degrees, this has an angle feature here. The gray calculators also have an angle feature. So I hit the second button to access it. It gives me all these options. So there's degrees number 1, and I want 13 minutes. And I go back to my angle thing, and I choose minutes number 2 to type in 24 degrees, 13 minutes. In parentheses equals 0.9120. Please, in your work, round everything to 4 decimal places in your work to get a good 2 decimal place approximation. And if I do tangent of 24 degrees, 13 minutes, again, tangent, 24, angle menu, choose 1, 13, angle menu, choose 2, to get 24 degrees, 13 minutes equals 0.4498 is that to 4 decimal places. Right? And once I've evaluated the cosine and tangent of these numbers, it's just a basic numerical proportion. I got this product here. It says solve the proportions that you can. So the ones we've written are the ones. Cross multiply 0.9120h equals 1 times 9.5. So to get h, I'm going to divide by 0.9120. And my calculator can evaluate that for me. So 9.5 divided by 0.9120. That's 10.416 repeating, so 10.42. If I go 2 decimal places. And if I look at the second proportion, if I cross multiply, 1 times y is y, and 0.4498 times 9.5 comes out to 4.2731, so 4.27. Again, round everything to a couple decimal places for a final answer. Throughout your work, keep everything to 4 decimal places. Right? So again, when you know one side and one acute angle, step-by-step process there always gets you the missing pieces that you're looking for. Make an answer box on your paper so it's easier for me to locate your final answers.